Manjari Modern School. So in the previous videos we are just going through the chapter number 4, that is chemicals and chemical changes. Okay students, so in that we have just reached up to the crystallization. What is crystallization? See here, we have seen that crystallization, which is on the page number 47, that is physical change. Okay, in physical change, any change in which no new substance are formed is called physical change. That is, for example, melting of butter, breaking of glass pane, and boiling of water. This involves changes in the physical properties of substance such as color, shape, size, or physical form. As such, no new substance is formed. Physical changes may not or may not be reversible. Crystallization is a physical process by which an impure compound is converted into crystal, and crystal are formed in forms of the compound that have a definite geometrical shape. Means in a compound, when the impure substance is there inside it, then that can be removed by the crystallization. Okay, so here what is first of all crystallization? Here I am just writing that crystallization So first of all, what is crystallization? The process of forming crystals of a compound from its solution is called crystallization. Okay, so what is crystallization? Crystallization means the process of forming crystal from its solution is called crystallization. If I want to just I have just dissolved salt in water, then how can I get back that salt? So if I say that if I heat that water and evaporate all the water to atmosphere, or after evaporating that water, then by the condensation process I take out that water, just water vapor converted into water, that process is known as condensation process. Then at last the remaining that are crystals of salt. Okay students, that are crystals of salt. Now another see here, this method can be used to purify the compound as crystal, leaving the impurities in the solution. Crystallization is an example of physical change, as no new substance is formed. Common salt or sodium chloride is purified by crystallization. It is prepared by evaporating seawater, and it contains many undesirable substances or impurities such as magnesium, chloride, and sand mixed with it. During crystallization, a saturated solution of common salt is prepared by dissolving it in boiling water. The solution is then filtrated to remove any insoluble impurity. The filtrated solution is then left undisturbed for few hours. Sodium chloride crystals well defined geometrical shape will be formed and the undesirable impurity will remain in the solution. Means we know the common salt, that is NaCl, that is taken out from the seawater. We have seen that from when we just the seawater is collected in the big thing, okay, vessels. So by that, when the sunlight come over there and after all the water is evaporated, after the evaporation of water, the sodium chloride crystals remain, and that is known as salt, common salt, that we eat. Okay, moving further. Here an activity is given over here, that is to prepare crystal of copper sulfate from an impure sample of copper sulfate. So a beaker, distilled water, powered copper sulfate, stirrer and dilute sulfuric acid are required. Method: take a beaker and add 100 ml of distilled water to it. Keep on adding copper sulfate to it with constant stirring till no more of it dissolves. Add half taste tube of dilute sulfuric acid to it. Heat the solution again. Add copper sulfate in small quantity while stirring till an unsaturated solution is formed. Filter the hot solution to remove insoluble impurity. Keep the saturated solution of copper sulfate undisturbed for few hours and you will see the blue colored crystals of copper sulfate with well defined geometrical shape are formed. Here they are just saying to see the copper sulfate crystals. Okay, and the next topic is chemical change. What is chemical change? Here chemical change a chemical change chemical change a chemical change is one in which two or more substance combine together, two or more substance react to produce a new substance with a different property okay. So what is chemical change? First of all we will see that, and then after we will see how the chemical changes occur. So a chemical change is one in which two or more substances react together to produce a new substance with a different property. When two or more substance or compound combine together to form a new compound, and then after its property is different from this both. Okay, this property is different from this both. Now here the another is, in this case there is a change in the chemical composition of a substance or substances. In order to produce a new substance, chemical changes are also called chemical reactions. Chemical changes are permanent changes. Let us discuss some examples of chemical changes occurring around us. See here, first is reddish brown deposition on iron objects. We know that in iron there is rusting. How it is rusting? Let us see that. Reddish brown deposit on iron object. So when the iron comes in contact with oxygen and water, then it start rusting. We have seen that no one just can break the iron, but when itself start oxidizing, itself break it. Okay. Now here, have you ever observed a reddish brown substance forming over an iron object such as a trowel, means kurpi, or axe, that is kundal? This reddish brown deposit is iron oxidized, commonly known as rust. It is formed when the outer layer of iron reacts with air and moisture present in the atmosphere. The process by which iron reacts with oxygen in presence of water to form rust is called rusting here. A definition is given. What the process by which iron reacts with oxygen in presence of water to form rust is called rusting. Okay, is called rusting. Here again, let us see the process by which iron reacts with oxygen in presence of water to form rust is called rusting. Means if I say iron plus oxygen plus water, what it will form? A reaction is given in your textbook, that is iron oxide, that is known as rust. Iron oxide. Okay, so iron oxide, which is also known as rust. Okay, then the iron oxide is formed. Let us see that here. Rusting is a chemical change because the chemical composition of iron changes, leading to the formation of a new substance, rust. It is also a permanent change since iron cannot be obtained black from rust. Let us write the word equation for this chemical change and reactants: iron, atmospheric oxygen, moisture present in the air, and product iron oxide. Therefore, the word equation for the chemical reaction will be iron plus oxygen plus water gives iron oxide. Okay, rusting is actually a flexy substance that does not stick to the iron object. As such, the iron gets exposed to the further rusting. Due to course of time, the iron object becomes weaker as more and more iron gets converted to the rust. Thus, in order to protect iron object from eroding, rusting must be prevented. The process of rusting can be prevented by cutting off either oxygen or water or both. Oiling or greasing iron objects prevents the outer surface from coming in contact with moisture and air, thus prevent rusting. Sometimes paint is also applied over iron objects to prevent contact with moisture of air. Another process is known as galvanization is also used to prevent rusting. from iron objects. In this process, the iron object is coated with a layer of zinc, such iron is known as galvanized iron. Here, there are processes when the grease is applied over the iron after a period of time, then it is just can't be rust because it do not come in contact with moisture in the air, and also it is painted, so it is also not come in the contact of the moisture. So and another is galvanization, in that a zinc layer is just there over the upper part on the surface of the iron, so that is known as galvanized iron. Okay, and there is an activity to show that the rusting of iron requires both oxygen and oxygen and water. Materials needed: 3 test tube, iron nails, boiled water, tap water, anhydrous calcium chloride, vegetable oil, and rubber crocs. See here, take 3 test tubes and label it A, B, and C. Place a nail iron in each of them. We have to put in Gujarati if I say khilli, you have to put in 3 test tubes, and then after pour a small tap of water in test tube A. Ensure that only half of the iron nail is submerged. Pour boiling water in test tube B. The water is boiled to ensure that there is no oxygen dissolved in water. Ensure that the iron nail get completely submerged in the boiled water. Add some vegetable oil above the water. Oil being lighter than water will form a layer which acts as a barrier between water and air, and hence air will not dissolve in water. And add a small amount of anhydrous calcium chloride in test tube C. Anhydrous calcium chloride absorbs moisture from the air. Okay, plug the mouth of the 3 test tube using rubber cork. Keep them undisturbed for 3 to 4 days. Observation: the iron nail in the test tube A will form rust, while the nail in test tube B and C will not form the rust, because in test tube B and C, in A, what we have done, we have taken we haven't given the oxygen, and in B we haven't given the oxygen, and in C we have given the water, and in test tube A water and oxygen both are there, so it will be rust. Okay, see here it is written, the nail in the test tube A received both moisture and air and therefore rusted. The nail in test tube B did not receive oxygen, while test tube C does not receive oxygen or moisture. This nail therefore doesn't rust. This proves that both oxygen and moisture are necessary for rusting. Okay, now moving forward, there is browning of vegetables and fruit surfaces. So what is it? First of all, browning of, we know that after some times the vegetable get a brownish layer on the surface, and also the fruits. See here, certain fruits and vegetables such as brinjals, potatoes and apples turn brown on being cut open after left for some time. This happens because a chemical reaction that occurs between the cut surface of the fruit or vegetable and the atmospheric oxygen. The product of this reaction is melanin, which is a brown pigment. Browning can be reduced or slowed down by soaking cut vegetables, fruits in water due to low solubility of oxygen in water. Here we know that everyone has seen that the mother cuts potatoes directly into the water. Why? Have you seen this? When our mother is making a sabji of potato, then she just directly cut that potato into the water. Why? Because it will remain outside in the air, then it will start form a brown layer on the surface of it. So in the water, the oxygen will not there. So she just directly cut the potatoes into the water, and also brinjals and other vegetables and fruit also. Okay students, so up to here we will take, and in your homework what you will do is, in your homework in your homework you have to do is, read and write one time crystallization, that is physical change. Okay, we will meet in the next video. Okay, bye students.